What's up, Internet? Today we are going to get Ableton to drive some individually addressable LEDs. We're going to do that by sending data out into processing, where we can ultimately communicate it via serial to Arduino, which is going to drive our Neopixels. Now, that's a bit of a complicated process. We are going to show absolutely every step end to end. This video is a little bit long. I've got it broken up into sections. There's code in the description if you just want to, grab it and get moving. Otherwise, from the top, let's do it. So you've got this data that you want to send out of Ableton into somewhere else. But what is that data and where does it go? Like, what rails is it riding on? In our case, that data is Midi. And you're probably familiar with receiving Midi into Ableton from something like a keyboard or a Midi controller. But in our case, we're going to do something that is less common, which is send Midi out of Ableton. This is the kind of thing that you would do if you had, say, an 80s synth that you wanted to power with notes that you wrote in the Ableton piano roll rather than a built-in arpeggiator. We're going to use this as something that Ableton can target, that it can send MIDI messages to, that lives on our computer so that the rest of the computer can observe it and read those incoming messages and then do things with them. So we're going to start by creating a virtual MIDI bus in OS X, which is our fake instrument that we can both send notes to and read incoming data from.
To create our bus, go to Audio MIDI Setup and then Window, Show MIDI Studio. In here, you should see something like this IAC device. Rename that to whatever we want. I'm going to call it Virtual MIDI. Make sure it's online. And then you can rename your bus to whatever you like. I'm going to use vbus_a. And I'm just going to save that, and we're done here. Now in Ableton, I'm going to go to Live Preferences. And this virtual MIDI with its bus should appear here. I'm going to make sure that for output, my tracking and my remote are on. And I also want to make sure that tracking is off for the input so we don't create a feedback loop where we're sending out only to send it right back in. In Ableton's instrument panel, you can see an external instrument which you can drag onto a MIDI track. And this will let us choose an output, like our target here, and when we play MIDI notes, it will send that data to them. Now we can't actually hear these, so you can create a group with this track, open the layers, and drag in something that you can hear, like this analog. And now when we play this track, we can both send MIDI data and also hear what we're working on. I've got this loop over here in Ableton now. It sounds like this. And that's just something that I can have playing. It can be muted so that it's not annoying, but as long as it's playing, we'll have some test data in the background that's just being generated. And then if it's paused, I can also come over here and use the computer keyboard to generate some notes whenever we need notes. So this guy's going to be open in the background. We're just going to pop into here on an as-needed basis. We've got a blank processing sketch here, but before we do anything else, you're going to want to come up to Sketch and Import Library, and then you want to add a library here. You want to look in here for the space MIDI bus. And I've already got it here, but you want to click this Install button, and then we'll be good to go. So processing starts us off with absolutely nothing here. There are two main functions that you're going to have in effectively every processing sketch, and those are your setup and your draw. Your setup returns nothing. It's a void function. Void setup takes no arguments. This is going to run when your sketch runs, and then the void function draw is going to run repeatedly every frame. Additionally, we are going to get a function called MIDI message, void MIDI message, that the library we're going to use is going to call every time we receive a MIDI message. MIDI message is going to want to take an input of type MIDI message, we'll just call it M, and we're going to get a complaint that MIDI message does not exist, and that's true. We need to import some of the stuff that we just installed. We're going to import the MIDI bus.star, everything from that library. I'm going to import javax.sound.midi.midi message. This is the thing that this was looking for. We can now declare a MIDI bus typed, we'll just call it MIDI. In our setup function, we can set that up. We can say MIDI is a new MIDI bus, passing in this vbus A is the name of our virtual bus that we created, and -1, which is an argument I don't remember that maybe I'll tell you in the video.
It specifies an output port. You don't need it. In fact, we could have just skipped it entirely, so don't worry about it.
We've got all of this set up. We can print line, got MIDI message with our MIDI message. So now we can hit play, run our sketch, and when we come over here and play some of these notes, you can see that we're getting MIDI data in here. And if we leave this sketch running, or we leave this loop running, it'll just keep generating. When we stop our sketch, we stop listening to it, but you know, that data is still coming in. We just don't have a processing sketch running to deal with it. These messages are great, but they're not terribly useful. Let's pull out some data from these MIDI messages and start actually routing it into things that are useful. Capture the int status via the getStatus function. And we will capture int message data from the part of the message via getMessage that we care about, which in our case is at the 1 index. This will be the message type. There are all kinds of message types. You have note on, you have note off, you have aftertouch, etc. And then this will be data like which note. We can create some functions to process all of these different kinds of events. Create a void function note on. Takes an int for the note number. And we'll create a note off that also takes a note number. And these functions for now can just print out note on. And then our note number. So we can say note off. Oh, duh. We're not actually routing anything to these yet. If our status is 144 is the MIDI status for note on, then we will route to note on, passing in our message data. 128 is our note off. We'll pass that same data. So now, if we hit play, perfect. Rather than all that gibberish we were getting earlier, we are now getting actual note numbers. You can see that the note number differs, depending on the pitch. These correspond to pitch. So it won't send you data like, D1 or C#2. It'll just send you a note 0 through, I think, 127, maybe 255. So we've got information about which notes are coming in, turning on, turning off. What I'd like to know is which notes are actually being pressed at any given moment. So I'm going to track those in an integer list that just holds all of the note values, like 66 and 67, that are actually being pressed right now. Create an int list called active notes. Just make a new int list right here. And now when a note is on, instead of printing this line, we will push it, active notes, push note number, push that number in there. But if it's already in there, we don't want to do that. We want to say if not active notes has value note number, then we want to do that. So we won't add it to the list if it's already in there. We'll only add it if it's not in there. Now when the note is off, similarly, we only want to do this if it's actually in the list. So if active notes has value note number, we'll do this thing. And if not, we'll just give ourselves a little warning. turning off note that isn't on. Note number. How do we remove an integer from an int list? This turns out to be a thing that's a little bit more of a pain. We've got to write a little helper function. We can say ActiveNotes.remove, but this thing wants an integer, but it's not the integer of the note number. It's not the value we want to remove. It's the index, the address of the value we want to remove in the list. And right now, we don't know that. So we need to write another function that is going to tell us that information. Int index of, because this function is going to return the integer representing an index. Representing the index of target data in a list, or -1 if not found. It's already mad, saying we have to return something, which is why we can return -1 just as a signal that things are not going well. So this index of function needs to take 2 arguments. It needs to take the int, call it target, that we're looking for, and int list source, which is the source that we're looking in. So for int I equals 0, while I is less than source size, we'll just loop over this, and if when we get the item at whatever index this is, it matches our target, we'll return the index. So now we can say int note index is index of our note number in our active notes list. And the thing that we want to remove, we can now pass in that note index. What are you mad about here? Oh, yep, that needs to be a plus sign and not a colon. Now on our draw loop, if active notes size is greater than 0, we'll print array. Will print array take active notes? Yes, it will. Otherwise, I'm just going to print an empty string to clear our spaces a little bit. So we'll restart this. And if we go over here and I play a chord, as I play a chord, we should expect the number of active notes to rise. Beautiful. So we now have a real-time list of all of the notes that are being played. So we're now getting the data that we need in processing. We can switch over to Arduino. The first step in the Arduino IDE is to make sure we have actually got a board connected, and I think I don't right now, which is probably for the best. So if I go down to port, yeah, there's Bluetooth and my headphones and nothing else. We've got an Arduino board, got a little USB cable, takes an A to B. I mean, whatever, if you're holding an Arduino, you already know this. Plug this guy in. So now we can go to tools, we can make sure our board is set to the right kind of board, and make sure our port is set to the right port. And if you have a higher end Arduino, it'll tell you what it actually is. Some of the Chinese clones won't say this. Don't worry about it. To start us off, we can go to File, Examples, Basics, Blink. This opens a new window. It's got a whole lot of explaining. All it does is set up one of these pins, the LED built-in pin, which I think is 13 on an Uno. It sets it up as an output, and then on the loop, it writes it high to blink it on, waits for a second, 1000 milliseconds, writes it off, waits for a second, etc. So we can hit the upload button here, and my board's going to be blurry, but you'll see him start to think about what's going on, and then ultimately start blinking at a 1 second interval. So those are the receive and transmit lights are going, and says he's talking, and now you can see that he blinks. So that's great. I want to steal the contents of this sketch and put them in ours, because this is a great starting point for us to start riffing on getting data in. We're going to keep this exactly the same. We do still want to use this pin in this way. But rather than turn these on at 1-second intervals, I want to turn this LED on when a note is playing. But before we can know whether a note is playing, we have to actually get that data in, and that communication is going to happen over serial. We can make a new variable up here of type character, call it serial data, and then in our setup function, uppercase serial dot begin at 9600 baud, which is kind of the standard for this. Now, in processing, this thing is now ready to listen. The serial port is open, but we need to actually send this data out of processing into Arduino. To do that, we will import the serial library in processing as well. Import processing.serial, lowercase here, .star. We'll just get everything from this library. We can make a serial. I'll just call this Arduino and a string val to send. Now in our setup function, our Arduino to be a new serial connection, passing in this, some stuff we don't know yet, and at that same 9600 baud rate. This thing that we don't know yet is the address, the port address that we're trying to send to. So the easiest way to find the address that we need here is to just print out a list of all possible options. I'm going to comment this out because it's not valid code yet. We don't have an address. It's going to yell. And in the meantime, I'm going to print array serial.list just to print a list of everything. I'm also going to turn off this other stuff. Otherwise, we would hit go, it would print our list, and then it'll shove that list off the screen with this giant deluge of MIDI notes. So now we're just printing the list. Hit go, and bang. A list of all possible destinations. We want the one that matches what's in Arduino. This is dev.cu, USB modem, whatever. Here is index 2. Now we can create a string. Let's call him port. Serial list get the second item of that and pass that in. There. So this will create a connection to the Arduino. We need to still send some data. So much like we were doing previously, we'll just send some of that data depending on whether there is node information. If active notes dot size greater than 0. So if we have notes, size is a call. If we have active notes for each of those, we can say Arduino, which is our serial connection, dot write. We can get this note and we can write that out. Otherwise, we'll just write 0. Now, there are other ways you could do this. You could potentially send the entire array as one piece of data rather than sending each piece of data separately. Chunking serial communication and getting it to arrive reliably on the board is a big topic, and it's super complicated. This is kind of like a fast and hacky way to do this. It ought to meet your needs, but if you want to get deeper into what it takes to send complicated data over serial, that's something you can look into and maybe go further. Now we can expect this data to be sent out of processing to the Arduino. Let's listen to it. So now that we're sending this data over serial to Arduino, let's come back to Arduino and get ready to listen to it. We have our variable up here ready to take in some serial data. In our loop, so every frame, we can say if serial.available, if we've got new data, serial data is whatever we read. So now we'll have serial data that is representing, whatever numbers are being sent by processing. Because we're sending 0 when there are no notes being pressed, we can use that to say, is anything being pressed at all? It's either 0 or anything else. So if serial data is 0, do one thing, else some kind of note is on. And we'll write high. Otherwise, we'll write low to turn them off. And we don't need any delays. We want to keep this snappy. I'll push him to my board here. There he goes. Stop and restart the sketch over here. So now with our board flashed and our sketch running, I should be able to come over here, press notes, and see this light turn on. Groovy. So blinking a little thing on this board might not seem like a big deal, but it totally is. We've got data coming out of Ableton, getting processed, coming into the physical world, and controlling real circuits. Everything we do from this point forward is just beautifying on top of this process that's already locked down. But at the end of the day, it's just data moving out of Ableton, onto the microcontroller and being used for stuff. So we're going to take this a step further. We're going to build this little LED strip that is going to let us control some pixel art directly from the Arduino. To make this, you're going to need a short strip of Neopixels. The board can't actually power that many. I've got 12 here. It's a pretty reasonable number. And then just a couple of short jumper wires. Here I've got white for ground, red for power, and blue for data, but you can use whatever you got. One thing to keep in mind is that the strips are directional. So when you see these little arrows, data expects to go this way. Make sure that your connection is happening at the bottom of this strip so that all the data is going to be flowing in the correct direction. I'm going to start off by getting just a little bit of tin on the pads here. This is a lot easier with the third hand and when you're not on camera, but I just want to get a couple little dots onto each of these pads. You can see that one's pretty big, so I'm moving it on to the next one. You might have a little bit of flux spread around, but when you're done, it should look like this, where you've got the pads well coated, but there's no solder moving in between them. Tin the tips of your connection wires a little bit, like that. Then you can heat that tinned pin to get it to lock that connection in. From there, it's just the same thing for the other two pins. And there you go. You can use a little bit of alcohol or a brush to get some of that flux off from around those pins, but it's not conductive, so those connections are going to be fine for us. So now we can connect our pins to the board. Ground goes into any of the ground ports. Our power goes into our 5 volts, and I'm going to use pin 12 for our data here. So let's get Arduino powering these Neopixels. We'll add a library. We'll come up to Sketch, Include Library, Manage Libraries. This screen takes forever, just be warned. Come on, buddy. There we go. Now we have to download the libraries index. This takes so fucking long. So you can search for Neopixels up here, and we want just the regular Adafruit Neopixel library. You'll be able to click install here, and then we'll be good to go. We can start using that by including the Adafruit Neo capital P pixel .h. Then I also want to define an LED count of 12 and define an LED pin that is also 12. So this is the pin we're using. And this is how many pixels are in the strip. We'll label that. We'll create an Adafruit Neopixel. We'll call it strip, and we'll give it a length of our LED count. We'll give it the pin number, LED pin, and then we need to pass in this other data, Neo GRB plus Neo kilohertz 800. Just like we started listening for our serial, we can now also begin our strip. Just as starting our serial didn't actually do anything, we've got to actually come down here and make some choices. The same is true here. Let's get rid of this. We don't need to be writing to the board pin anymore. Let's write something new. We want to write a color to all of the pixels. How about that? So for int p 0, p is less than LED count, plus plus. We'll loop over all our pixels here, and then for each of these we can say strip set pixel color, pass in our p, strip color. We can pick anything we want here between 0 and 255 for RGB values. So let's go RG all B. Then outside of our loop, we can strip.show. This is a somewhat expensive call, so if you are working with a lot of LEDs and find yourself having significant lag out of nowhere for what seems like no reason, a lot of times this is in your loop and just chugging memory. Let's push this to this board and see what we get. We get mad is what we get. I'm missing a parentheses. Let's go. There we go. So now we got all of our pixels here being written blue. All right, this guy really wants to fall off this thing. Let's keep going. So right now we're writing all of the strips blue all of the time. We can do something similar to what we were doing before, where if the serial data is bigger than 0, we're writing these guys blue. Otherwise, we will write them dark. Now let's upload and make sure your processing sketch is not running while you're doing this, because only one thing can talk to the serial at once. So we need that serial port while we're writing to the board. And then now that it's freed up, we can come and start the sketch. So our sketch is running. I'm just going to hit play here. So as we play notes here, we see these things light up. Make sure we stop our processing sketch here. And then we don't necessarily have to have these off. The board LED has on and off only, but we don't necessarily have to have off be off. We can off be a little bit blue and on be all the way white. So now our board is mildly blue by default and bright white when we play a note. So now I've got Ableton set up with a drum kit that is also sending an external instrument out to Midi. So, you know, we're done with this guy. I've just hooked up a little drum kit. I got a bass line under it that is, you know, making sounds, but not actually sending any MIDI data. All the data is going to come from the drums. I have recorded which MIDI notes correspond to which of my drum signals. I've got multiple kicks going on at once, but I only need to listen for the one since they're both firing at the same time. And then over here in our loop, I have broken up this strip into a couple different sections just based on the pixel count. So one of them is kick, one of them is snare, and depending on whether the serial data matches that particular drum sound, I'll do something different. Turn off all the lights, sort of recreate what we did in the demo here. That ends up looking something like this. And over here, we've got this lower section that represents our kicks. Our snares are this big flash of white in the middle, and then the hats are just kind of rattling up top in the last two, doing this kind of fluttery strobe pattern. One of the things I've got going on here is the strip's off color changes a little bit based on what pixel it is. So it doesn't show up well on the light, but if I stop this, you can see that it kind of does seem pinker over on this end, and then it fades to a more traditional blue over here. And what's happening is that hue is being changed more and more as the pixel count rises. You know, the math, the multiplier here starts to rise. And so that hue is shifting over the strip. So there's a little bit of interest when it's off, and then we're writing these different colors, you know, all red for the kicks, all white for the snares, and then a milder white, sort of a light gray for the hats, just because I want the snares to be the thing that are really jumping out here. So that's it. You are driving LED art from Ableton. You have everything you need to find some creative uses for these numbers and go out and make something really cool. Right now, our sketch says we have 12 LEDs, but if you've got the 5-volt amperage to power it, you can have 1200, and this process works for things that are the size of a room, and you can expect stuff like that going on in future videos. I'm working on some very fun prototypes right now. But this should get you started. Please do feel free to drop me questions in the comment if you need anything. The code is on GitHub, so you can get a hold of it very easily. And if you have suggestions for future videos or topics you want to see me dive deeper on, go ahead, like, subscribe, and let me know so that I can create the stuff that you guys want to see. Take care.